Hi everyone. I feel awkward sitting down, but I think it's better for the camera. I'm Adrian. I work at Opscode. I've been working in cloud computing for the last year and a half, mostly on the open source project jclouds. I'm going to talk to you about Java and Clojure and cloud computing and the tools that are available to help you out with that. The agenda, first I'm going to talk about motivation, like why you would need like specific libraries to help with cloud computing functions. And for that I'm going to use the topic of key value stores and Blobstores, and we'll talk about what that is and some of the implications of it. I'll go into the project, and then I'll speak specifically about two functions of cloud computing. One is like storage based. In this case, I'm talking about Blobstores. And then the other one is provisioning, like starting new Linux nodes or whatever else you might need. So before I get started, I'm just curious, how many people here have used either like EC2 or Amazon S3? And how many of you have gone to a cloud computing presentation before? All right. How many of you are currently running cloud servers? Okay. All right, so I'm going to go and I'm just going to overview, and I have a lot of material here, and we'll get a lot of code examples at the end. So it should take about an hour to get through all of this, and you know, hopefully I'll make that. So for the first, I'll go over motivation, and this was sort of like why did I end up spending a few thousand hours coding in Java to make cloud computing easier, and to review that, I'm going to talk about what cloud storage is in this view, some of the vendors that are involved, and some of the differences into how they act. So key value storage means a lot of things, especially if you're working with NoSQL products. You'll definitely identify with this. For the purpose of this demonstration, I'm going to talk to you about key value cloud storage providers. And all of the ones that I'm going to refer to have the following things in common. One is that they at least attempt to create like a global namespace. And what that is like, for example, if you have a DNS name, that's global, right? Because if you go to yahoo.com, you can pretty much be assured that there's one authority responsible for that. So we're kind of used to dealing with namespaces on the internet. And so a lot of these cloud storage providers try to do the same thing, so that you have one way for all of your customers, wherever they happen to be connecting to get to the data. The other thing is that when I'm talking about key value storage, it's unstructured data, normally stringify keys, and then all of them have metadata as well. So it's only a slight improvement on the formatting, but it actually lets you do a lot of interesting things. For example, if you think of key value store as storing images in Facebook, the XY coordinates for where you are in that photo could actually be attached as metadata or something like that. All of these are HTTP accessible. Almost all cloud APIs are that way, and there are many reasons for that are pretty obvious to folks. Being a cloud service, one of the key components of a cloud service versus just a old school hosting is that all these services are on demand. It's not just having an API to data, it's also having an API to provision spaces, like provision new namespaces, tear them down, creating sites, tearing them down. Like everything, if you can do anything you need to do via API, it lets you enter the world of like a cloud service versus just a ticketing system. And from the user perspective, a lot of cloud services have the perception of unlimited scaling to the user. It's not unlimited, obviously, but the idea is that the service provider probably has petabytes of resources in the case of cloud storage, and your likelihood of using those up are very, very low. And so to the user, unlike their own resource pools, this is going to feel like an unlimited amount of resources. And so these are some of the concepts about key value storage I'm talking about as far as clouds. And before I go any further, does anyone have any questions on this? Because I'm going to drill down on this a bit. Yeah. All right, so the questions are, one is, what was my motivation? personally, why did I get into this? What was my background related to it? And the other one was a question about privacy concerns of the data that's outside of your network. So, you know, I was actually working on a JBoss project called, well, it was the successor to JBoss Cache. It was called Infinispan early last year in January. And my role in that project was to create the adapters for data stores. And so I'd worked on like Berkeley DB and stuff like that. And as this was a new data grid product, they actually enhanced the integration testing to the point where a lot of the libraries that we were using before failed. So we had a Amazon S3 connector to persist the data store of the grid. And the idea was if you're running like your data grid in EC2, at the time there was not like EBS mounted storage available for the root volumes. So people were looking for places to actually persist the snapshots of the grid on a frequent basis. And so we were, the previous plan was to use S3 for that. When we ran the new version with a new increased testing, the libraries that we used suffered from concurrency problems and other sorts of problems that prevented them from working. Also, it was pretty much impossible to run in Google App Engine. And so I took the the task of either making existing libraries work, and solve these concurrency concerns, and that actually turned into creating a new library. I spoke with the authors of the cloud computing libraries that were out there, like JetSet, which was written by James Murdy, who wrote the original O'Reilly book on Amazon clouds. And he ended up joining a project which is now jclouds, and so we focused the first half of the project just on cloud storage. And the first customer of that open source project was the JBoss Infinispan grid. Now it's much larger, and services such as like Sonian, who do email archiving, use it as well. But there are several customers now. My background, why I was chosen, was I had a lot of JBoss and WebLogic clustering experience in my career. Most of my career was actually spent doing what we now call as DevOps roles, and that's basically that kind of glue between the development process and the operations process. So I did like a lot of middleware management, and replacing like Bob's scripts with some more elaborate processes to control deployments and such. So actually getting into the data grid was kind of a departure. I enjoyed it. So yeah. Now, privacy. So the thing about cloud is that cloud is not just publicly available services. And when you get into it, there are a few things that you can consider. One is that there's a difference between an API and a service that's exposing the API. So, for example, if you have a Amazon S3 compatible library, it should work whether you're connecting to Amazon service or your own hosted Eucalyptus version of the service. Like there are some cloud software packages that you could actually install, open source or otherwise, in your own network. The most common solution to the privacy concern is to encrypt on the way out. There are other patterns too, but that's what most people consider doing. And that way it's useless unless you have the secret key. So again, drilling down, if you just think of these two things, global namespace and key value, you can pretty much follow the rest of this stuff in the code. So what I'm going to do now is I'm going to talk about how the vendors in the more predominant vendors in the Blobstore space handle these concepts. And so there are others, actually, and there's also a standard coming out called CDMI, which is run by a group called SNIA. So right now there's only one standard key value API as far as cloud services, and it's a de facto standard, and the de facto standard is the Amazon's S3 API. This is implemented by Amazon. It's implemented by a Eucalyptus product, open source product. is also implemented by Google. Google has a new data API that also implements S3. You find like another, local tech company, Terracotta, actually exposes their data sets via S3 API, and the EH cache has. You'll find more and more products implement the Amazon S3 API than others, but there are still deviances between even the way that those work. It's sort of like dialects in English. If you go north to south, sometimes you can't understand what people are saying. It's the same sort of thing. But I'll talk about how all these vendors handle the problem of key value storage. And the key is that they're really not the same. There are service differences. For example, how the services handle file size. So in Amazon, most of the Amazon S3 related systems, the limit on an object size is 5 gigabytes, and that's how much you can send in one request. It's also not resumable. So, for example, if you lost a connection at byte, 4 gig 999, you have to restart and send the entire thing over again. And so what happens is with APIs like that, people tend to like hack around it and like chunk up their data and then pass that burden onto the client side. Microsoft Azure has a more sophisticated system. They actually do random access reads and writes with their API. And if you actually look at their product offering, Azure has a very good reason for that. How many of you are familiar with NTFS or have at least used it? So NTFS is like the network file system in Windows land, and Microsoft actually implements NTFS mountable blobs. So if you can actually download the disk image file via the blob API, and then you actually have your file system. So it's very, very slick. And the only way that they could get it to work where actually you could mount a blob is if you could do random access write to it. And so that actually gives them the advantage of being able to do things like a file system mounted on it. But the other thing is that it helps you with resumability. So when you consider like the cloud storage provider you're going to work with, you do have to consider the limits of file size and how resumable they are. The other thing is that you have to consider highly with cloud services specifically are data physics. Do you need a content delivery network? Do people know what a content delivery network or CDN are? If you've used it, raise your hand. Okay, for those of you who haven't, a CDN is basically the idea of caching content local to the users. So generally, it's not like a cluster. It's a multi-master thing. It's generally a cache, and what that does is it allows you to, have your users in Tokyo look, feel, and act as if the data was close to them. The downside is that if they were doing uploading, that they would pay a big price in latency and performance. Some clouds are actually very sophisticated, and they use actually multi-master. In Nirvanix, you can do up to 3 masters out of 5 locations, and their 5 locations are like there's West, Southern California, Dallas, and Frankfurt, Tokyo, and a few others. It's actually more than 5 now. And I talked to the guy in charge of Nirvanix, and he said that if people would pay for more than 3 masters, they would offer it as a service. And it's actually something you're going to find about cloud services in general, is that they're very consumer driven. So we're not talking like drink Pepsi consumers. We're talking about people like us consumers. So I found more than a couple clouds actually offer significant service offering differences over the course of months based on customer demand. So for example, you have a business requirement that has I need data in Sydney. It is a fair question to ask of a cloud service provider, what's your story there? Because they might actually have that on the router, and they might just be waiting for a quorum to be met. The other thing is replication. Some people use cloud storage because they want to offload the burden of replicating their data across multiple sites because of whatever reasons, regulatory or otherwise. So it's another fair question to ask of your cloud storage provider and consider when you're using their API if the service behind it automatically replicates or whether you have to replicate manually if you want to have survival in a disaster scenario. And what this all turns into is your SLA. So if you look at a service like Nirvanix, which is the first cloud service to offer an SLA, as they'll tell you, their single master service is 99.9% uptime. But if you have 3 locations, they'll do 5 nines. And if you use interesting tools which replicate across clouds, you could get a lot of nines out of that. These are a lot of things to be considered with, but it's not assumed that they're going to be replicated. So for example, if you look at a new storage cloud like Rackspace, they only offer 1 location. So they're not interchangeable in that way. Any questions on that sort of thing? So the other thing that bites many people as soon as they start using cloud services is you have to actually program around the architecture of the service. So an API, like for example, it's a GET request or a PUT request, actually doesn't tell you anything about the consistency model underneath of the service. So the consistency model says that, okay, if I write a record into this service and I read that key right back out, will I receive the record I just wrote, or is there some sort of a delay? For those of you who have used like software deployment services in the past, like Marimba or whatever, you may have noticed that when your deployments are going to like UK and you're in California, there might be like some minutes before it actually makes its way over there. That's called eventual consistency. So a lot of services actually do offer eventual consistency as a default answer, not immediate. So in that regard, you can't use this for like transactional type of data because if you need to make sure that you can read back the record, like the update, so that you don't have overlapping write, it's not going to work for that. Most people don't even try to use a Blobstore as a transactional system anyway, so it's fine. And the other thing is that if you're dealing with just the need to put like large gigabytes of content, it doesn't matter either. But it's a fair question to ask. Since a year and a half ago when I started with this, services have become very fancy with their answers to customers' concerns. So for example, a lot of people have complained about the Amazon storage services because the underlying Dynamo system was always eventually consistent at the time that I started with it. And by the end of last year, they started offering the customer choice. I'd rather wait a little bit longer and get immediate consistent. So basically the service would hang there, wait till it syncs, and then return the connection to the client. And so the other things like, for example, Terracotta, with their data services, you can actually tune the consistency model at runtime. So for example, for those of you who have worked in batch systems will know that there's times when you get just a ton of stuff that needs to load into the system. So sometimes it's fair to actually turn off the consistency model because you're just throwing a bunch of stuff in and then turn it back on afterwards. So you're going to find a lot more advanced approaches to consistency handling. But the most important thing is just to keep it in mind. Because if you try to pretend as if it's like a MySQL database, it's not going to work. Any questions on this one? That's a very good question. So the question is that how can I figure out the capabilities of my cloud? How do I know ahead of time, before I start writing data into this thing, whether it's going to be eventually consistent or immediately consistent? And this is actually one of the least evolved features of cloud APIs is a capability system. Some of them do have it. Like for example, the simple DB system, you can actually choose per data set what consistency model you want to choose. But most of them you have to just know. In jclouds, for example, I don't have a slide on this, but we actually expose a consistency model, our best information based on it. And it wasn't really just a choice to be really nice. It was because we do live integration tests, for each feature. If I didn't know the consistency model, I don't know whether to wait and retry, or whether it was my code is broken. And so this is the whole reason why I had to deal with this problem in the first place. And one thing is that the consistency model you'll find is that it's not limited to just storage services. Almost all cloud distributed systems are like this. So even if you use like compute APIs and things like that, they may not always be immediately consistent. So if you say like delete this system, it might actually show up for another second or two, even though it's deleted. So it's all global APIs you should be considerate about. All right, authorization. This is another immature part of cloud APIs. Most of them do not have authorization models that you can access. Some of them do. In cloud storage, you can at least set like whether it's private or not, like on your data objects. And basically, when you set it public, you get like a URL that somebody could literally put into their browser and access. And I mean that's why this cloud storage is so popular, because you can get like sometimes a reasonably looking URL out of the service itself and just treat it as like a web server or a static web content server. But some of them get pretty fancy with authorization, like you can create sub-accounts and delegate access and all that stuff. But most of them don't have that. The best you can hope for on most providers are your typical ACLs like users and groups. But even that is pretty primitive compared to what we're used to in file systems. And then the last thing to consider is API complexity and how much time you're spending on each of these APIs and trying to figure it out. So for example, if you're working on an S3 capable cloud API, it's probably not a big deal to move from that to another S3, even if it's a dialect, it's not a huge amount of code effort. But if you were working with something like Microsoft Azure API and then moving to S3 and back, it would actually be very different code to achieve the same goal. And some of it is even the approach, not just the objects, but the strategy you take. So for example, the strategy for uploading a large file in S3 is simple, put it there. Whereas in Azure, you have to break it up into bits and then send it. So this is a big concern. And so I'm actually going to show you what some people love this slide, which shows you what they sort of look like. So here are a few, and I'll just point out, I guess you can't see my pointer. So on the top left, Amazon, you can see that the way that this HTTP request is structured is fairly intuitive. In this case, I have the color blue here for those of you who aren't color challenged, representing the global namespace or the container. Most of them call it container or bucket or something like that. And so you can see that a lot of them have fairly intuitive placement for that. In my opinion, the most intuitive place is Amazon's, because it uses a DNS name for that. DNS also has another advantage of letting the service scale better. If any of you have worked in trying to create very large HTTP accessible systems, you'll find that you can actually move clients off onto their own server farms if you use things like DNS, whereas it's a lot harder to do if you use like HTTP paths. Azure is also pretty intuitive there. Rackspace is kind of weird, where they encode like the API version and an account number into it. So if you think about it, when you look at these put requests, you're really looking at what this is going to look like when a user gets it. So if you re-expose these APIs and you use like Amazon service, then if I wanted to give Amazon URL off to a customer, I would say like Adrian's Movie S3 Amazon.com/sushi. It looks kind of nice. I mean, it's maybe not perfect, but it's acceptable. Whereas if I had a URL that said like Rackspace/API version/account number/this/that, you probably wouldn't want to give that URL directly to a customer because it doesn't really brand that nicely. You had a question?
Actually,
Yeah, that's a good question. So the question is that versions in this context, not versions of my objects, but versions of the API. Yeah. And so yes, most services offer multiple versions on the same API. It's a reasonable expectation, but it's not assumed. Especially if you look at a new cloud API, if you look at the company and notice that they haven't been in the business of creating publicly accessible APIs, I would not assume that they're good at this. However, if you look at like an Amazon who have been successfully creating APIs, you can pretty much assume that they're going to maintain a backwards compatibility. Most of them actually ask you to pass the version in the request, and then they can route accordingly. So for example, the company I work for, Opscode, they have a platform which actually routes according to the version number. I know that for a fact. And the guy who wrote the Opscode platform wrote the EC2 API. So I can pretty much assume that also works. But if you didn't know, you have to ask. And most of these have great forums, and just ask the question. But good question. You'll find like the people who are working with newer cloud APIs struggle like they did when you were working with EC2 back then. There's one thing I find very interesting about cloud APIs in general is how immature a service is, but yet people are still willing to put it up for the public consumption. So I mean, this is something that you're not used to in packaged software. As a packaged software is generally fairly baked before it's thrown out there, whereas a lot of the cloud APIs throw errors on a regular basis, and that's actually a code consideration. In fact, in jclouds, I actually code for errors. There's a lot of error handling code just based on maturity issues. But anyway, a few points. I don't want to belabor this too much, but coding and signing is important. So for example, some services like Rackspace use a session, and others allow you to sign individual requests. When you sign a request like Amazon has, then you can actually delegate that request to someone else. So I can actually create and construct a signed URL, even for uploading an object, pass it off to someone else on another network and have them upload it. And that's how you can do this pattern called side loading, which is where people can actually get a signed URL from a cloud and then upload in their browser to an area. And it's probably the most fine-grained access control you can get, because at that point they can only affect that one object in that one way. So it's actually very nice. Whereas it's kind of impossible to do that with Rackspace, because the only way to delegate is to give your key or your session, and your session is basically super user for the entire cloud. So these are very, very interesting code concerns. For example, say I want to have a service like Flickr, and I want to allow people to upload potentially large images, and I want to run the cheapest service possible. Well, what I don't want to do is get in the middle of that upload. So I want my server only like delegating and handling stuff, but I don't want like the data actually passing through my Apache instance and then storing into S3. What I would do instead is sign a URL, pass it back to some JavaScript in the browser that would then upload directly. And then I can run very cheap service in that way. And that way you're really using the cloud very efficiently. Right, so the question is that when this is signed, how long is it valid? So in the case of most services, they have a SKU of 15 minutes. And some of them you can actually put different expirations on the request. It's a SKU based on the likelihood of your clocks being out of sync with the service clocks. But people also use that as sort of like a hack to give you some wiggle room. And in case you're going to ask next, it's the time that you actually make a connection to the server, not when the last byte is received. So that way you can still have them send like 5 gigs over the next 2 hours or whatever, as long as that connection doesn't break. Okay. And then the other thing is that the question is that how many requests do you need to perform to produce one function? Very quickly I found that I cannot create a software for cloud computing that would assume that each API requires one command to do the same thing. So for example, in the case of Nirvanix, I actually have 3 commands to upload a file. One is essentially to create an upload area. The other one is to and that's basically a namespace. And then the other one is to actually to get an upload URL, and then the last one is to put the file. And it sounds like a lot of steps, and it is, but that's how they handle multi-master. And so that's the only way they can make sure that you're going to write closest to the user, because they need to actually open up a space on the local server and then give you the URL to send it through. If that's a pretty complicated example, but it actually speaks for itself. I mean, you do have to consider these things if you're actually to write these things. So at the end of the day, you have to ask yourself a question. Do you want to deal with errors of cloud providers, concurrency glitches, complexity of the systems, or complexity of dealing with systems like Google App Engine, where they restrict things like spawning threads and loading classes and stuff like that? And if you do, you should be a member of jclouds or some of the other cloud library providers. And there's a lot of open source options, not just Java. For example, if there are options in Ruby and Python and other things. But if you don't, then you should probably use a library to do this job for you. And that's one of the reasons why jclouds is becoming more popular. We had a few goals, and obviously one goal is to be open source as Apache licensed. And the other thing was this, to feel like the language and not feel like you're working with a REST API. Dealing with portability between clouds is important. But one of the other things that we added was the ability to allow you to access all the features of the cloud. And this is actually kind of an interesting point. If you're actually going for pure portability, what you find is that with the level of maturity of the service providers, you actually cannot solve most customers' needs. It's not like JDBC or something like that, where everyone has pretty much agreed on how things work. Now you probably find yourself in a situation where you have 95% of your code in this portable way, but you need access to the underlying driver for like 5%. And that might be to do like access controls, because those are all different between all the providers. And the way I look at it is that you want pragmatic portability, and that's to like just contain the chaos as much as possible. And that's one of the things that we try in jclouds to do. So we provide like the native API for each of the cloud services as well as a portable one. We also put in a lot of work for unit testability. If you can imagine running your tests, and if you fail, you've accidentally created a new server, or you've accidentally deleted your entire customer's database by accident. So this is the most important piece. And this actually came because when I was coding jclouds, I was on a bus around Europe, and my network connectivity was terrible. And here I am trying to write a cloud API. So I'm just writing stub simulator providers and stuff. But this is the more mature cloud libraries like Fog and Ruby and jclouds all have stubs or transient providers, so that you can have your developers test against this without giving them your credentials, and also saves them a hell of a lot of time. You're talking about like the difference between an integration feature test going 20 minutes and 3 seconds. That's how much productivity there is. Go ahead. The question is that how realistic are the stubs? And for example, in the compute provider we actually do have a multiplier for how long the delay is, so you can create like a simulator for a fast cloud and a slow cloud. In the case of the Blobstore stub, we don't have an eventually consistent version right now. It's all immediate consistent, but feel free to add the issue, because I'm sure some people would like that. And then the last point here is to make sure it's thread safe and scalable. So because we had the data grid roots, now we've kind of been bound to them. So we are a core plugin to the data grid, and also we're used in Elasticsearch platform and some other platforms. And so we actually have to always make sure that it's always thread safe. Otherwise, it would look really bad for the library. And one other point I don't have on the slide here is that it's just as important that you work in the cloud as working to connect to other clouds. If you have services like Google App Engine, Google App Engine is a very, very attractive place for developers and sometimes, production applications because it starts free. So essentially you can deploy a WAR file and it's hosted for free. The downside is that it's basically, I don't know if anybody's used like the security manager in Java. Most people have tried like once and then they turned it off and never tried again. But essentially it does things like restrict your ability to do IO commands and spawn threads and such like that. So our ability to work in Google App Engine actually had a massive design impact in how we actually created the product. So for example, you can unplug and plug in a different encryption service, a different date processing service, different HTTP transport, and a different executor library. So for those of you who like concurrent stuff, we have we swap out the executor service in Google App Engine so that even though we return things like features, they actually are performed in line sequentially so that they work in Google. And in a newer version of jclouds, we're going to take advantage of the recent advances in Google App Engine's API set, where they actually give you an async HTTP library. This was added to Google App Engine about a month ago, and we haven't quite caught up with that. But pretty soon we'll give reasonable performance comparisons inside of Google and running in your own system. So it's pretty cool stuff. So we provide tools, we provide abstractions, so abstractions meaning that the portability layers for Blobstore and also compute services. We cover a number of providers, and I probably have left a couple out, but there are a few Blobstores, and there's an increasing number of compute providers. Including the IBM Developer Cloud, which was a very recent addition, and that's a free service. For those of you who want to get a free $100 credit, GoGrid texted me earlier, and I have a code for you. So this is for new accounts, and if you enter the promotion code GGPLO, GGPLOW, to a GoGrid enlistment account, you'll get $100 credit free. The other thing we do in jclouds is which is more recent, about 3 months ago, we started accepting Clojure as a core competency. So the Clojure bindings of jclouds are written by some superstars in the Clojure community, and you'll find that if you use Clojure, they look and feel very nice to you. And we do some third-party library integration as well. For example, when I say third-party, I actually mean third-party open source. We don't actually have, we don't do commercial integration in our project, but like Apache Commons VFS, we have a file system driver for jclouds. So for example, if you wanted to, put an SFTP server on my Blobstore, you could use Commons VFS to do that, which is pretty interesting. Alternatives, you can roll your own, and if you have, there are a few cases where this is actually reasonable. They're diminishing, but there are a few cases. One case might be that you are working at a cloud provider who's not going to change their API, and so there's no sense in actually creating something to enable another API for your business purposes. I've worked at a cloud before, so. But even then, that's a diminishing, because most cloud providers now are looking more like exposing multiple APIs than preventing APIs. So when you look at like network file storage, sometimes if you like buy the NAS device that you can get at like Best Buy, and it has like a CIFS provider and has WebDev and all this other stuff, you're going to find multiple protocols on a lot of services increasingly. The other thing you can do is you can use like a REST client like Jersey or REST-easy and just mark up the commands. jclouds was written with JAX-RS annotations, so you could actually look at the code, copy and paste those annotations on your own classes, and try it out. I mean, you're really going to get other problems later, but if you really wanted to try it, just to get familiar with it, go ahead. And then EC2 APIs are more powerful than you think because everybody's trying to be like them. It's like be like Mike. So if you use EC2 APIs, you're probably going to work at least a few clouds because a lot of them are exposing these things. There's a significant amount of Java libraries like Typica and Jetset that work with EC2 and S3. There's a library called Design, which was written by another cloud star named George Rees. He wrote the Cloud Application Architectures book. And incidentally, Design Cloud uses jclouds as well, but there were some providers that it has that were written before jclouds. So they actually have a larger set of services, but we're pretty much partners on that. And then there's service providers actually produce SDKs most of the time. So I'm now going to go into some code, but I'll let some people ask questions if they want to. I think you had your hand up earlier. So who uses jcloud? So there are a few open source projects. So there's the JBoss InfiniSpan for Blobstore. There's Elasticsearch, which essentially uses both the Blobstore and the provisioning APIs. You can actually provision your own search grid with it, and it also does discovery. There are a couple commercial projects like there's Sonia, which is email archiving. There's Makara, which is a web app deployment platform that uses for provisioning. There's open source tools in Clojure. There's, for example, Palette, which is kind of like Chef in Clojure. Design. There's I actually have a list on the project site with about 10 or so choice customers, but and Stratus, which is a cloud management platform that uses jclouds underneath. There are more than a few. Yeah, we're very I guess conservative with the versioning. So we still call ourselves beta. We're like beta 6 now, and we're gonna have beta 7 shortly. And I actually told folks that I'm not comfortable releasing version 1.0 until we have 10 compute cloud APIs, because I noticed that in the storage side, until I got to number 5 of the storage cloud APIs, my abstractions stopped breaking. So I want to just get a little bit longer in that. But the project's been alive for about a year and 4 months now. We have 7 regular contributors, there are some customers that are pretty big that I cannot mention, but those are the ones that I can. Okay, so code. Here's what it looks like in Java to create a connection to any of the service clouds or the transient, like in-memory store. And so all of our APIs are location aware. So there's like a global namespace generally, but there's also a concept of the service itself. So for example, in Amazon, you can choose whether to have your blobs live in Europe or Western US or what they call US standard, which is actually a weird quasi area in between East and West. You have other services like Azure who have like 7 data centers. You can choose your master. So we actually have a query for looking up the locations that are, it's actually called list assignable locations, and you can choose one. But if you don't choose, you can just hit null and it'll pick the default. And the default is based on your endpoint. So if you're using like an endpoint that resolves to US West, then that will be where your data ends up stored, or your compute nodes end up. And we support multiple payload types. You've got file, byte stream, byte arrays, the usual suspects. And in this case, we're looking at because it says get Blobstore, this is a synchronous API. But if you use the command get async Blobstore, all the signatures are the same, just the return value would be a future. And then it's a Google type listenable future. We use a lot of the Google libraries called Guava. And listenable future is really cool because you can attach a runnable to it. So essentially I can say, fire this off, And then in my runnable, I can say like post a message on my, RabbitMQ. So I can essentially just fire and forget and then, create workflows with it. So that's why we use listenable future as opposed to regular future. Any questions on this one? All right, got a lot of content, so I'm gonna move ahead. Commons VFS. This is an Apache project. It's been like pending version 2 for years. We're on the version 2 API, and hopefully it'll settle at some point very soon. But basically, you can open up a Blobstore just like you open up an FTP site. And so you can actually copy things to and from FTP or SFTP or content management sites. Closure. So this is an example of how to do some closure stuff. We shorten the commands, and we also have an interesting feature that uses closures called with Blobstore. So for example, if you look at this command, I create a Blobstore object, and then I specify that as a parameter to my query of containers and query to get blobs. But if you actually wrap this with Blobstore and then specify the Blobstore name, it will infer the Blobstore that you want. So you can actually wrap an entire suite of commands without having to specify it. And it ends up looking a little bit cleaner. Sorry, I have an older slide here that's not as pretty, but I'll show you later. So I'm going to do this real fast. I went to GlueCon the other week, and I did this one in 20 minutes. I'll try and do it in less. And I'll cover the good, bad, and ugly of cloud provisioning, and then show some more code. So the good part of provisioning in a short spiel is that provisioning new nodes, like sets of Linux boxes, Hadoop grids, whatever it is that you want to provision, is generally cheap if you're doing it for a short amount of time. So if I need something for a few hours, then certainly you're talking about something that doesn't make even any sense to think about like buying a machine. And reprovisioning them is also cheap because by virtue of the fact that you're using APIs to do this, then you get away from like the Bob script problem where like somebody named Bob knows how to like do all this stuff, and you actually have like an API and it must actually be repeatable or else you wouldn't have been able to do it in the first place. So reprovisioning at the point that you're using a cloud to do provisioning is very cheap. The automation opportunities with cloud APIs are getting better and better and better. So not only, like for example, in EC2, if you didn't know already, you can do things like provision reassignable IP addresses that can you can have a static IP that can be reassigned to different machines, which is called elastic IP address. You can provision the equivalent of SAN volumes called elastic block store. You can take snapshots of them, which is crucial. If you look at the most important feature in a compute cloud, I'd probably say it's snapshotting, because if you can't get your backups done in a very short amount of time, then it's almost already a showstopper for folks. And there's tons of other APIs out there, but when you start looking at all the opportunities, your automation of doing your entire data center build out in a suite of commands is more possible than you'd think. The things that are lacking are like network and security controls. If you look at, there are very few APIs that give you access to things that your core network and core security folks would be doing. Like for example, setting up edge routers and stuff. That don't expect that right yet, but that should come. But they're not quite there yet. And the other good thing is that tools exist, not just jclouds, but other tools, and not just tools as in libraries, but tools as in platforms. So platforms that deploy on top of something like an infrastructure provider. The bad part is for developers forgetting to turn things off, because you are indeed built for everything. So and also licensing, but about forgetting to turn things off, I do it all the time, and in fact that's one of the reasons I've created more scripts in more pliable languages like Clojure, because it's very easy to forget that you launched something in Europe and then you're only looking in US or something like that. So one of the recent advances in jclouds, like I said about the locations, is that when you do a list of nodes, it actually lists every location in that cloud, including like Singapore or whatever. So if you have something in your account, it'll show up. But definitely remember to turn them off. And sometimes you don't want to. Like some people like hack around billing cycles. So some certain clouds bill you for an hour regardless of how much of that hour. Some of them do like increments, like a calling plan on a mobile provider. So sometimes it's worthwhile to leave one running if you know you're going to use it another 15 minutes from now. But generally speaking, it's easiest just to turn something off and get a new one next time. It shifts the focus from knowing the internals of how to troubleshoot stuff to knowing how to reprovision it. And once you get into the reprovisioning game, you feel very confident and you're okay like wasting the extra 3 cents that you might have saved by turning something off. Licensing is a bad part. It's not just from licensing, like, are you violating your enterprise license agreement by accidentally deploying like WebLogic in the cloud? But it's also about the licensing costs of the images that you're using. There are a lot of value add, like appliance type images, like for example, F5 load balancer image or something like that, that you get charged maybe a trickle charge based on traffic, or maybe it's actually a one-time hit. I accidentally launched a few licensed images once and had a $720 bill in a day for something I never even cared about. So just be very careful about the images that you use. And then the other thing I talked about earlier is the service quality, especially the new APIs. The service quality is pretty poor, but even the nice ones, the service quality is erratic, and you have to build for that. It's sort of like if anyone used to remember this Genie, and like the Java Spaces stuff, like you would actually code to deal with the network. You really should pay attention to that. And like jclouds actually has back-off limited retry handlers and some other fancy things to like try again in various intervals, and so does JetSet actually. That's where the code came from. But there will be times when the entire cloud API is down, and you should plan for that. The ugly is that the APIs themselves are unreliable. So it's not just the service quality of the instances, but you can't even tell if the instances is running or not if the cloud itself is down. So you have no information. It's sort of like, in this case, your servers may be running or they may not. If anyone have done a disaster recovery exercise in your company, you'll probably identify with this, where like crucial systems you're used to dealing with, like email, everything else, your API is sort of like email. So if you deal with cloud APIs all the time and that goes down, it's sort of like dealing with a few hours without email or without Twitter. That's the way it feels. APIs are very different across clouds. Tools like jclouds and Fog and Palette help with that. Features are very different. Be very careful about the features you bind yourself to, because it will make your application extremely hard to move. And so basically they've got you. You may actually choose, like I've actually seen in the IRC room someone say, lock me in. Because if you have a really nice service, people are not going to really be upset. It's more about like this is sort of like a prenup. It's not about the marriage, it's about the divorce. So think about it like that. You don't want to get yourself too involved here, because there's not a lot of credibility yet with these cloud services. Most of them are only a year old at best. You don't know what dials they're going to turn as far as pricing is concerned or service quality. And the other ugly part is accidental complexity. Like for example, Amazon's cloud is very good at a lot of things, and if you have anything as popular as that, everybody knows all of its warts too. And there's some things that are very, very hard to do in some services, like for example, converting from one image to another. These types of things are what I refer to as accidental complexity, because whenever you get into a situation where it takes you a lot longer to explain how you do something than what you're trying to do, there's generally accidental complexity there. And there's some examples, but most of them are image related, or the fact that you have to pull APIs to tell whether something's running or not. No API currently allows you to do like callbacks. Like if I start a server, I have to keep checking, is it done, is it done, is it done? It doesn't actually have a callback to like let me know that it's done. So people, what they do is they spin up like RabbitMQs that pull these APIs and then invert with like a Redis store the control, and you have to do a lot of fancy things to make something like look and feel and behave the way that it might should. And some other things to consider when you're provisioning. Can you even create an image? Some cloud APIs don't even have image support. So don't think everybody's Amazon. That's the best thing you can do when you're moving clouds. Assume nothing and ask basic questions. It's like, you can get into a car and you can have a relative assurance that it's going to have a brake, but you cannot get into a cloud. It might not have a brake. So just go through and methodically ask these questions. Can I create an image? Can I save it? Can I get my data out of the cloud? Is it possible? Is there enough bandwidth for me to pull my data in? So it might be a very attractive cloud. They might be giving you free data import, but then there's no export API. So you have to ask these questions. Can I assign my own credentials for logging into these machines? Do I need to VPN in? For example, one of the more secure clouds is Terramark's cloud, and you don't actually get a public IP address attached to any instance in their cloud. Everything is behind firewalls. And so even to do something like SSH, you have to punch through with a load balancer to get access to it, which is generally a smarter idea when you're talking about more enterprise stuff. But some people who are used to casual security, like in Amazon's cloud, it becomes a problem, because then you've baked all your assumptions based on the idea that my server has a public IP and no firewall. And you have to ask yourself these questions. The other thing is, how is storage provisioned? Can I ask for a larger disk? Is my disk going to survive reboots? And can I create an independent volume and then reattach it to another instance and do things like MySQL slave stuff with that? Not all clouds do that. And the final thing here before I get into some code is the question, how close are my dependencies? So this is like a data physics question. So am I dependent on a data store that's on the other side of the globe? Just because it's responsive to get to my apt repository from my laptop, it means nothing about how close my cloud is to that same repository. So if you're doing software installs or you're doing data import export, remember that your cloud is different than you. It's not on your network. So it's somewhere else. It might be faster, it might be slower. You have to make these tests. And the best hint I can give you all on this one is to go to cloudharmony.com. It's like eHarmony, a very cheesy name, but it has a lot of blogs about choosing the right cloud, and they do regular performance tests, latency tests, saturation, all this stuff. So you can find out a surprising fact is that there are clouds whose local disks on the 5 cent an hour machine are faster than the fastest Amazon machine on their fastest SAN. And so just because something says medium, large, extra large, it doesn't mean anything, right? There's no universal currency here, and there's not even a currency exchange chart, but the closest thing there is the Cloud Harmony blog. So here's, this looks very familiar to the Blobstore example for jclouds. It's intentional. All of our abstractions follow the same convention, so you don't have as many what the fucks. So I'm using that term because one of the goals for creating a project is to reduce the amount of WTFs that developers, when they start using it. So we try to keep everything consistent. What we do here for cloud portability is that we try to create semantical equivalence. So in this case, if I want to get the largest node possible, I can actually query for that, and that will match in any cloud and pull the largest size. Now, it doesn't wash away your responsibility, but at least you can then not have to know the specific ID. And this code, if you pasted it into any cloud, will work, and it will get the largest based on predicate queries. You can also do OS family Ubuntu, and it will find the highest version official image of Ubuntu in that cloud. And this is how tools that work on top of jclouds like Palette and Whir, which I'll mention later, actually can operate, because we test these, the default template to make sure it always works. And so users don't have to even specify anything. In fact, you can actually leave out the argument template, and it will just choose whatever it can for you. So if you're using a higher level tool that knows the difference between how to provision something with CentOS versus Ubuntu or whatever, then you really don't even need to know the OS, especially if you're Java. When you get into serious enterprise grade stuff, obviously you're going to need to want to know the exact image, and you can specify that like .image ID. But if you're a developer and you're just wanting to start without knowing any complexity problems, then I would recommend trying out just the default templates. Leave the problem of choosing. You want to separate the problem of choosing the platform to the folks that are good at that. And if you don't care and you're just a casual developer, then we've chosen ones and we test them every release.
Can you just explain what a template is and
what
the use case is?
Yeah, I got ahead of myself. So in jclouds, a template is a combination of a few things. A size, which includes like CPU, memory, disk specification of size. An image, which is an operating system produced by some entity, either the cloud themselves or another contributor. A location, which is what I mentioned earlier about the physical location that it resides in, and options. And these options are like here, for example, I can specify my SSH keys that I need to log into this, and any script that I want to kick off. What we don't do in jclouds is like implement a tool like Chef on top of it inside the same project. Our goal is to like do a warm handoff to other tools, and that's why we can like focus. So we focus on just getting you to run something, and as soon as you can run something portably, then you're set. For example, in our live tests, we install OpenJDK, and as long as we can get like Java minus version to pass, then we know that cloud works. And also for people in this room, that means everything that you probably work with also works. But the template is the idea of like a specification, and what we do is we specify it in terms of your requirements as opposed to terms of specific IDs. So my requirements are like OS family this, or my requirements architecture x64, or things like that, and there are a bunch of parameters you can use, as opposed to saying M1X small, image ID AMI dash whatever, which then binds your configuration to that cloud. So it's not just about code, but it's also about configuration and discoverable configuration.
So this is doing what to remove hosting? This is saying, give me the biggest server I can get right now, please?
Yep. And it's going to use my default operating system. So that .any says, use all the defaults that jclouds has baked in, which jclouds bakes in, the default is to get the smallest image of Ubuntu or Red Hat Enterprise Linux variant, either CentOS or Red Hat, in descending order in the default location. So if you specify nothing, that's what you'll get. If you specify any, then that will say, okay, with these assumptions, now what? And this says, okay, those assumptions, but now instead of the smallest, make it the biggest. There's also one called fastest, which will get the highest core count. So this is actually just, this is what we build in, but you can actually build your own template system if you wanted to. It's actually not terribly difficult to do, but this is where I expect some services to actually come in the future. So if you think about it, like, for example, the Opsco platform could house like the configuration data that you want for all of your nodes, and then it could plug into this, and then your developers don't have to necessarily choose these things. Based on query, they could just say like delegate to this, and then this service would handle that. And I think that's actually a much more scalable situation. And in this case, it's going to launch five servers and group them by the tag web server. So if I query later, I can get those same 5 nodes back by that grouping. If I run it twice, I'll get 10. And so this is additive. And we have a predicate-based system for performing commands like stop, start, reboot. And there's default predicates for like node IDs or tags, but you can also create predicates like contains IP address pattern, whatever, if you wanted to do more fancy, sophisticated stuff. Our goal isn't to like solve every one of those tooling problems, but just to make sure that the API has a means to do it. And so I would expect for people to like contribute their own powerful, expression languages or template builders or whatever as time goes on. Other questions? Okay, so the question is that, how do I debug my code without being billed? So we have a provider called Stub, and Stub simulates creating nodes. What we don't have is actually a Stub SSH daemon to like test your scripts. We do, but we don't have one that's very easy to use. For example, it uses mocking, and most mockings are not thread safe. So for example, we have our Stub itself actually does respond to this command, but only because I set up all the expectations like you would in normal mock testing. So you can look at the code that we have in our stuff for how to do like SSH mocking. So you can see like, okay, like I use easy mock, right? So I do like, create mock SSH connection. Like, because remember earlier I said that everything's pluggable, so is SSH. So I actually unplug SSH and plug in an SSH mock. We also unplug HTTP and plug in an HTTP mock. So when I do things, I can actually see the HTTP request and make sure all this stuff happens. So as a developer, you have more tools than you would expect, but sometimes it's just a hard problem to solve. So sometimes what it's best at doing is to, contain your chaos. So instead of making a massive shell script that does like a ton of things, you might want to switch to like an open source product like Chef that has like tested recipes, and then make your bootstrap action fire off this and then execute the list of recipes, because then just like code, all you have to do is test the fact that you bootstrapped something, as opposed to test the fact that you bootstrapped it and then it did this, this, and this, and this. So what you want to do is really think of operations the same way you think of code in general. Modularize, don't mix concerns, and you can do like everything we have here is already unit test. So, and if you have any questions about how to do it, just ping us on the dev list or just look at the code. But there are ways to do it, or else we wouldn't have this. For me, it's not so much about the cost, because I had a discussion earlier that our Stubs compute provider was the latest edition. It only came in our last beta. And the reason is that personally, I had so much work to do that I didn't care about the $3 I'd save. It took me a long time before the pressure raised up to the point where I cared. And it's not about the $3. It's just about the time, because I don't want to wait like 3 minutes for the cloud server to run up. And it is not easy to create Stub for compute service providers. So there's a lot of time. So eventually you cross that threshold and then you're like, okay, I'll do it. And so I was on a plane for a while, so I did it. But I'm going to show you some more code. I want you guys to see some things. Okay, thanks. So here's another one I mentioned, design. This is design. Again, it uses other functionality in jclouds, but one thing about design you might be interested in is if you actually use a lot of the cloud services that Amazon offers, like a lot of them, then design might be a better choice, because it exposes things like their security groups explicitly in a cross-platform way. So like when jclouds is about making a lot of sensible default choices for you, and design is exposing all choices. Now, there's a middle ground in jclouds where, like for example, you can access that provider API and you can inject other things, and we have some cool things like power user mode for EC2, where you can like specify even more things. But in general, if you have a lot of requirements to pass, design might be worthwhile at least looking at. Whir is a very cool project. This is done by Tom White. If you don't know Tom White, he wrote the Hadoop book. He works at Cloudera. He's working on new revision. So he had a lot of experience provisioning Hadoop and Zookeeper and these things. And so a while actually, I think he got a bit of ridicule for like having shell scripts in the source repository, considering everyone's either like a Python or a Java developer. So remember that threshold? I think he crossed the threshold and he just made this knockout library called Whir. And Whir is about controlling clusters. And it rides on top of jclouds. So like I mentioned, our goal is to stop and make sure that we can focus. So we stop and like Whir picks up. In this case, you can actually create a service spec. In this case, we're creating like a Hadoop service with one master and one worker. But it's the appropriate abstraction layer for this system. One thing that's very easy to do is try to do everything like in a shell script. But when you find like yourself like talking, about more about clusters and you're talking about like machines, then it's time for a new abstraction. And this is one of those examples. And so I'm really excited about this. It works. It's a new incubator to Apache. And they also do cross-language. And not cross-language like as in Jython or whatever, but cross-language as in a complete version ground up in Python. Just like Google App Engine has a Python and a Java, and they try to keep them very similar conceptually. This is an example of that. So in this case, you could swap out the word GoGrid with any of the providers. Currently, we have 7 providers that we work with in jclouds, and it will work. So it's pretty sweet. You have Chef. So I work at Opscode, which means that you're going to get a lot more provisioning functionality in jclouds about like total systems management. I started working on the Chef and also their hosted service, which is going to be released next week, called the Opscode platform. And so the things you're going to get are like better control over your nodes, a central repository where your operations folks can use whatever language they use to do operations stuff. And coherent recipes and run lists and everything else like that, but accessible via Java API, which means that if you use like cool tools like there's shrink wrap, which is a really nice, very modern archive API for Java, and it can like collect things like you could actually generate a Chef cookbook on the fly and then pass it up to the Opscode server and then have all of your nodes run it. So if you needed to do like a software deployment or change the structure of your apps, you can do some really amazing stuff now. So like I said, my personal goal, and I think it's a shared goal across the jclouds type of stuff, is that to like not only like meet the other languages and what they've been able to do with provisioning, but actually go beyond it. And where I find a lot of the beyond stuff is where we get into the closure land. So jclouds has native support for closure. I mentioned in Blobstore. This is how you can use this closure what I mentioned earlier. This is an example of a mix-up where you have like portable APIs and Amazon-specific API mixed into the same block, which is cooler stuff you can do in closure, which is a lot harder to do in Java. And in this case, we're building a template and we're specifying this run script. And then once it's done, we're going to create and attach an EBS volume to it. And if you've ever tried to create and attach an EBS volume, it's generally not done in 5 words. It's much more. And it gets even better. There's Crane, which is actually solely focused on Hadoop right now, but they're working on general clusters in a way similar to Were. But this is currently actually tied to Typica and JetSet. But I'm working with these guys at the end of the month at the Hadoop Summit. We're gonna try and swap this out to use Palette. And Palette is one of the cooler tools out there. This is a DSL enclosure for provisioning, and you can mix and match tools. You can mix and match bootstrap options, and you can create your own crates. So for example, there's a crate a crate is sort of like a recipe in Chefland. And for example, there's one for continuous integration. And you basically put in your GitHub URL and your cloud credentials, and it will start up a node and provision, Jetty, Hudson, everything else, and then start it polling. And it's pretty sweet. Some of the things that in Palette, like what you find is that creating stacks for like one-shot deals are very good. When you look at any system, you basically look at it from a scale perspective. So you wouldn't necessarily use Palette to control like 100 nodes at the same time because it's using like SSH push technology. You'd probably use something like Chef. But if you're doing like my own setup for like a continuous integration or my CouchDB stack, it's a viable option. And the other cool thing I really like about it is that it actually also integrates with Chef. So you can use Chef stuff too. And so it's basically solely up to you. It's not even a lock-in to a specific DevOps tool. In this case, what happens is that the converge command will look up the cloud, look up the tag web server. If it has 3 nodes already, it will just reapply in an idempotent way whatever the configurations are. If it's only 2, it will provision another one and then reapply it to all of them. If you put in 0, it will destroy everything. So it's very sensible in a few characters. And the main difference in palette is that you'll notice the def node here. That's a function that is above and beyond the template in jclouds. So it extends and changes that to also specify behavior, bootstrap behavior, and configuration behavior. So like what happens as soon as the node is launched, in this case it will set up DNS and create like a system user named whatever my current login username is, so that I can just do SSH Adrian at this IP address and it just works. And then anything else you want to configure once it starts up, which are like gems, things like that, like in this case. So an hour and 44 minutes later, I'm done. So open for more questions. All right, well, I would say that the best way to interact with the jclouds community is IRC. The way I feel like is IRC is for heartbeat and email is for letters home to mom. So you'll get some response from the mailing list. You're going to get it like, if you send a message, I'll generally respond the same day most of the time. But we don't like say I'm doing this, and we don't use Twitter for all that stuff either. But there's generally 9 or 10 people in the jclouds on Freenode. So if anybody wants to log in and stop by. I also have this meetup group called Cloud Hackers, and there's a GitHub repo called Cloud Hackers / Cloud Demo. And I have demos of the closure code, also an Ant task that you can do, like all these provisioning commands via Ant, so you can plug it into your existing build scripts. We also have a demo in the jclouds code base for running in Google App Engine. So it's completely compatible, and you can use both provisioning or the Blobstore APIs in Google App Engine. All right, well, thanks a lot for lending me your ear. Please join the community. Yeah.